Okay, now let's get some practice drawing resonance structures using one or more of the 5 resonance patterns. So let's look at problem number 1 up here. First thing we want to observe and maybe do ourselves is where are the lone pairs located in this structure. Sometimes the lone pairs can help us decide where we might see resonance. Remember that resonance occurs with pi bonds and lone pairs, so we need to identify all the lone pairs. The first pattern that we should recognize, and there's actually 2, I'm going to show what I think is the simplest one, is the pi bond between 2 dissimilar elements, and that's shown by the arrow right here. And so let me erase that arrow, and then let's look at the curved arrow that we need to affect that resonance pattern. So we're going to take the electrons that are in the pi bond, we're going to push them up onto the oxygen. So we're going to create a third lone pair. We're going to create some charge here because we've left behind this carbon had 8 electrons, now it only has 6. The oxygen had, it had 8 electrons, now it still has 8, but its formal charge has changed because we've changed the oxygen state. It had 2 bonds and 2 lone pairs. Now it has 3 lone pairs and a bond, and we know that that formal charge is negative. And so now we have one of the resonance structures. There's a couple different ways we can go here. We could observe that the left side has the lone pair adjacent to cation resonance pattern, and the right side has the allylic cation resonance pattern. It really doesn't matter which way we go. It's important to remember that there are 2 possible ways to go from this point, and so we should make sure that we do both of them before we're done with this problem. So let's look at the first one, and that's going to allow us to create a double bond between the left oxygen and that middle carbon. And we've now taken the cation and put it onto the left oxygen. We still have a minus and a plus. That adds up to 0 like we started with. And now we can attempt to work on the other resonance pattern, the the allylic cation. Now to do that we need a arrow that looks kind of like this dashed arrow. I'm not going to draw it from here because it gets confusing when we try to do several resonance patterns from the same molecule. But I can draw that same arrow here, but of course if I stopped there, this middle carbon would get 5 bonds. So I need to push electrons back to the left oxygen. And that allows me to get to this structure, cation on the right carbon here, where we've removed some electron density. We're back to 2 lone pairs on that left oxygen, and I still have a negative charge on the top oxygen. And so these are the 4 resonance structures that we can draw from this starting molecule. And I started by trying to find the simplest resonance pattern and just doing that. So I'm going to draw the fewest arrows at a time. I really don't want to start drawing resonance structures using 6 arrows to move electrons around, because ultimately you're going to skip a few of the possible resonance structures. And we don't want to miss any because you get full credit only by showing all of the possible resonance structures. So let's look at number 2 now. The first thing we observe is that there's an aromatic ring. So let's just quickly show that resonance pattern by moving the double bonds around the ring. It doesn't matter which direction you go, because of course the image is the same at the end. So that's one pattern. And the next pattern is going to be this lone pair next to a pi bond. So it's an allylic lone pair, and we know that that requires 2 arrows in order to show the pattern. So I'm going to draw something like that. And so I have now a cation on the nitrogen. I have a lone pair on this carbon with a negative charge. So I have a plus and a minus, adds up to 0. I haven't created any charge. Now you'll notice again that I have an allylic lone pair if I use the pi bond in the ring. So let's take this lone pair, same arrow push. I'm going to put this one down. I can't squeeze it into the right side there. So let's go down. Again, I have the cation on the nitrogen. It's still a quaternary nitrogen. Now my lone pair is in the ring. I've destroyed the aromaticity, the 3 bonds in a row, but that's okay for now. And I have this resonance pattern, which again gives me a pi bond next to a lone pair. Again, the allylic pi bond, so I'm sorry, allylic lone pair. So let's keep repeating that same pattern. I have the cation on the nitrogen. Negative charge is now sort of migrating itself around the ring. And I think we can probably do this once more before we run out of options. So we have, within this ring, we have 3 allylic lone pair patterns. And so again, you'll see on this resonance structure, we'll just sort of put brackets around the whole thing here to show that all 6 of these are valid resonance structures for the starting material. And again, I started by doing the simplest changes I could. I drew the fewest number of arrows. I needed 3, of course, for this first pattern, and I needed 2 right here. But I could have used a whole bunch of arrows to get down to this structure right off the bat. And that would have skipped a number of structures. So we want to use the fewest number of arrows we can. Typically it's 1 or 2. Very occasionally it's 3. If you find yourself drawing 3 and 4 and 5 arrows to start off in your resonance drawings, you've probably skipped some of the possible resonance structures. So you want to go back and try to do a more simpler arrow push to start things off.